Hi everyone, I will tell you about this small app I built. It's called Doggos. What it does, it downloads image of dogs from the internet, downloads their breed list, sub-breed list, and show it all to user. It's kind of example app. It uses some of the popular technologies like async display kit, PromiseKit. It uses Viper, application coordinator, multi-threaded CoreData. It also has some unit tests in it. So let's talk a little bit about async display kit. Async display kit is a library initially developed by Facebook, which allows you to put some work on the background threads instead of putting it on the main thread. I mean, views related work. So you can get this smooth scrolling performance even on the older phones. Like even when not all of the images are loaded, you can hardly notice some frame drops. Okay, so uh, this application uses promises inside interactors and inside services. Let's take a look how it works. We're gonna go to presentation layer, modules, breed list, interactor. Here we go. Let's take a look at this method. It's called obtain breeds. So the presenter doesn't know from which storage it obtains breeds. Maybe from the local storage, maybe from the internet, it doesn't know. It just wants to obtain breeds as fast as possible. So firstly, we try to obtain breeds from the local storage. And only if this promise fails, then we try to load breeds from the internet and then save them. And then we report about success or report about failure. What is nice thing about promises is that you can get this really strict representation of your pipeline of actions. Like you can see the consequence of every action, and if you haven't got any complicated logic, like if you have only if you have to only to decide whether you have to fetch from the internet or from the local storage, then promises are probably the best way to go, but a good way to go. But if you have some more complicated logic, then you possibly shouldn't use promises there, because it probably will end up with a lot of recovers, catches all over the place. So, okay, let's take a look at this method: load breeds from the server and save them. This method returns a promise, and inside that promise we try to load breed list, then we try to save it. Let's take a look at this save method. Uh, this implementation of this method lies inside the protocol extension persistent saver accessor. So persistent saver accessor is a protocol which basically what it does is just obtain save tasks executor and forwards this message to it. Save task executor is the single instance object inside our application uh, which manages of saving core data entities. Let's take a look at this method. So this method also returns a promise. It dispatches this saving work to the serial saving queue asynchronously, and then when all work is done, it reports about success or reports about failure. So that way we can be sure that none of the other saving operations are performed while we are saving something in core data storage. Okay, so another thing I wanted to show you is this screen. This is the view controller presented modally. You can dismiss it by clicking this cross button, or you can dismiss it by dragging it. So this is the interactive animation, and what is nice about this animation, I will show you. We're gonna go to view controller. Right here is that we can manually control uh, the animation flow. So I have this cancel decimal threshold, and if the user's finger travel distance is larger than cancel decimal threshold, then we mark our object that responsible for transition as we mark this transition as that it should finish. And if user's travel distance is less than this threshold, then we mark as it should cancel. So we can do like this, and animation cancels. So it's kind of nice to think about what if user would touch screen by accident or something. We can see this switch right here. It's a switch called subreads. What it does is includes subreads in our um, application transitions flow. So if we will turn it off and we will click Bulldog, we can see the screen with image. And if we will turn it on, then we will see Bulldog subreads. What is good thing about Viper is that it's really easy in Viper to reuse some of the is to reuse views and maybe even other Viper objects. This view is just a reused view from this screen. Let's take a look at this subread. Okay. So you can see that there is another animation, a custom animation inside this app is image like unwrapping on the screen, and there is a background that is blurred while this animation is being performed. But we can see that this image kind of moves straight forward from the small frame to the big frame with this spring effect. So let's take a look at code that does this. We're gonna go to core layer helpers, above blur transitioner, image details present animator. Okay, so this is the object that is responsible for implementing UI view controller animated transitioning protocol, and one of the method inside this protocol is animate transition using transition context. So here we set our frame and perform our animations, and in completion we say that we need to complete transition. What is nice thing about this method is that we can use UI view property animator, which was available since the iOS 10. And what's good thing about it is that we can really easily to modify our animations. So let's try it. Let's add animations with a delay factor. Let's set the transform property for our image view. Let's use all transform property and rotate it. We can rotate it by 180 degrees, and then we can rotate it by 180 degrees once more. So let's take a look how it will work. Okay, so let's open any image like this, and as you can see we have this rotating animation. It's really easy to modify them. Okay, so now let's speak a little bit about tests. This project uses Moya, so it's really easy to uh, perform to write our stubs with Moya. It has some default methods. We can use our remote service, for which we can use initializer and specify the stub closure, like immediate stop that is specified right here. So it's really easy to provide default values for our responses. Yeah, well, we have all of the network related code assembled in one place, so uh, it's really convenient to write remote tests when we have such a tool. And let's open it up. So we use promises inside tests. So we set up the expectation, and if the promise succeeds, then that means that parsing of the object has succeeded. We fulfill this expectation. If not, then we fail it, and then we fail our test. Okay, let's take a look at the local tests. So what is essential for the local storage tests is that we need to keep the local storage refreshed and clean before running every test, because we need to be sure that we will fetch breeds the exact same breeds that we just saved. So what we need to do is to set up our persistent store before every test, or we need to refresh it. I have this persistent save task executor special initializer for that purpose. It uses persistent container mock, and we create this mock right here. This is the persistent container, which uses store description, which specifies an in-memory store type. So that way, before every test, we will refresh this in-memory persistent store, and we can be sure that we save that the persistent store will contain only those breeds that we are using in test start. Okay, so this code available on the GitHub. I will put a link down in the description, so feel free to check it out. And thank you for watching. Bye.